For a landing gear door of a C-130, if it gets damaged today, it's 4 years lead time before they can replace it.
4 years?
4 years.
Ed, coffee, tea, or something else? What fuels your mornings?
Usually I do one glass of, one cup of coffee and then bajillion teas. So coffee's already done, and this is the first cup of tea, and I'm probably gonna have like 5 or 6 by the end of the day.
What tea?
Just black tea.
Just black tea.
Toward the afternoon, I start doing maybe sometimes green tea, and then at night maybe a chamomile. But most of the day is black tea, English breakfast.
You're getting that water intake. That's good, at least.
Yeah, water and caffeine. The two things you need,
Yeah,
right, to run a company.
true. Yeah, no, very true. When you were a kid, what did you think you'd grow up to be?
I actually haven't didn't form an idea around it. I really like technology. I was like obsessed with computers. I remember I would go to my cousin, I was younger and my cousin had a computer. And the first thing I would go to their house, I would be like, okay, just where's the computer? Put me in that room, lock me up, and I'll do the things that I need to do. And until I think I was 6 or 7 when my parents bought me one. But I was obsessed with computers and kind of making things. It was just an amazing world, like where you could just with few click of a button, you can make things happen and build things out of your imagination. So I started
Yeah,
learning coding very early on. So I was really fascinated by that. I knew it would be related to something with technology, but I really never really had have formed a thought around, I want to grow up to be this. I wanted to grow up to just do cool things with computers, I think, at the time.
awesome. Awesome. So tech from young. Love that. What's one technology that you can't live without?
Oh, interesting. I think obviously phone is probably now, I think my main computing device. I can send emails, I can do, you get very efficient with phone after a while. I think initially I thought
Yeah,
I wasn't, it's a small form factor, but now I even code on my phone.
really?
I do image editing on my phone. I do most of my computation actually on my phone. So I love it. And I think I think chatbots are becoming part of it. I think chatbots are something that I use daily, and for different things like image generation, coding, proofreading stuff. I think those are getting close second.
It's true.
Well, honestly, though, if you want, it's the question, but it's kind of odd thing. I mean, we always, when we say technology, we go to this place where what is the advanced thing I want to use? But I mean, hot water, right? Like
Yeah,
nobody can live without it. It's actually a technology, right? Like we don't think about it. I think the level of comfort and productivity just hot water provided humans is like probably 10 times phones or whatever, probably,
right,
right? But we just
right.
take it for granted. It's like, oh, that's not technology. That's just like hot water. But imagine, if hot water didn't exist, our level of comfort and productivity would be significantly in a different place.
Yeah, it's true. I mean, we obviously default to the phone, and it's not just a phone, right? Now it's a whole computer in your pocket. So I think that's become the standard, like hot water for us. Like, oh, we just take it for granted, and now we've got this whole crazy amount of power in our pocket. I've had people say just transportation as well, because I can't get anywhere and stuff like that. But it's always interesting to hear what people say. But hot
I
water's
think
a
I can
new
get
one.
anywhere on my phone pretty much, right? Talk to
Yeah,
anybody, connect to
Uber.
satellites, you can go everywhere.
Yeah, true. I had speaking of the small form factor, I used to work for a company years ago, and the CEO kept trying to challenge himself to do smaller and smaller form factor of technology. So he obviously had his desktop, went to his laptop, then he was just using his phone, and he went through like a week of just trying to do everything from his Apple Watch. And this is before they were actually as advanced as they are now. So I was like, it didn't go that well, but it was an
That's
interesting
commitment.
test, right?
I'm gonna go as small as form factor possible. No, I think phone is where I'm comfortable right now. Who knows? Maybe
Yeah,
when the voice interface becomes really well, you just talk to it. I mean, but also you don't
true.
want to sound like a lunatic walking around talking to something. Um,
Yeah,
but if
it's like those
maybe he starts
glasses.
reading your mind, right? Once you had a
Yeah,
Neuralink and you start reading your mind, then the phone will go away, right?
true, true. All right, last one of these. If you could fast forward 10 years and see one impact that your work has made on the world, what would you want that to be?
I think really it's all about kind of what fundamental human need, I think expression, right? If I think expression has been very limited in the physical world. If through us people are more expressive. There's more physical products being built, and more iterations of that. I think that's a exciting world to look forward to. I talked to I had this story I told, I tell with my nephew. He's like 12 years old. He came to me the other day, a few weeks ago, came to me and was like, "Hey, I'm going to school. I want to build this build this mock design in an aircraft that's like super futuristic for a project that I want." And it was amazing that we could just use a chatbot, kind of delegate it to chatbot and use it and like come up with this amazing design that he was really proud of. And in a matter of seconds, we went from his ideas and his imagination into a design that was on the computer screen. If we can connect that, and that's amazing. I think this is just like, can't stress how crazy that is, that we can go from our designs, like some vague idea for something in our head, to actual manifestation of it in real form in the computer screen, and you can print it and move it around. If you can connect that to actually a physical product that can be built as fast, I think we have accomplished more than what we set ourselves to do, right? Like if we can kind of go to physical metal designs from our ideas in the next 10 years in just fully autonomous chain, I think the world is going to look very different than what it is today.
Powerful. That's powerful. Well, welcome to Machine Minds, everyone. I'm your host, Greg Tarusian, founder of Samson Rose, your robotics talent search partner. And on today's episode, I'm joined by Edward Mehr, co-founder and CEO of Machina Labs. Thanks for being on the show today, Ed.
I'm excited to be on the show. Thanks, Greg.
Appreciate it. Let's jump into it. So you've had a really fantastic and fascinating career across software, aerospace engineering, etc., all before founding Machina Labs. Can you share a bit about your background and any key experiences that shaped your perspective on manufacturing?
Yeah. So, when I grew up, I went to a very kind of the all boys school that had a lot of focus on craft and building things and kind of trade, right? So very early on, I was like very busy with my hands trying to build things. Got super fascinated with computers right around like when I was like, kind of like middle school, even earlier, but like very much more practically fascinated in middle school because it was this world where you could just do anything, right? You could go from idea to implementation of it just by yourself and a computer. It felt very empowering. But at the same time, I was learning carpentry, welding, and when I was at school, and that was fascinating. That was like a very good, having that tactile experience was very important, but like it felt very limiting. So I'll like right from like my teenage years, I had this experience of like a virtual world, sounded like amazing amount of possibilities. But then there was this physical world that I really liked and I wanted to be tactile with and building things, but it just felt like it's going to move much slower. I ended up choosing my career to be more closer to the computers. I went to school as a computer engineer, started doing internships like Microsoft's and Google's and Sony Electronics of the world, but very fascinated about what computers can do. Got gravitated toward more machine learning toward the end of my undergrad, so I spent a lot of time there too. But eventually, I remember one day I was walking on campus and I saw it's a small group that was talking about SpaceX. This is like 14, 15 years ago. It was a recruiting team from SpaceX that had a small little table at USC campus, and they were saying, "Oh, there's this rocket company that like is building rockets." And I've like honestly, I've never heard of any private company that does that. I was like, "Who are
Yeah.
these lunatics? What is that supposed to mean?" I know NASA is building rockets, but what are these people doing? And I was like at the time really fascinated by my internships at Microsoft and Google. And, it was fancy. We worked 5 hours a day and we were, having lunch catered and, making a lot of money and feeling important as a grad student there. And this small company was like saying, "Oh, they're building rockets." And there's like, "Why don't you just come for a visit?" And I ended up going um, 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 to see the facility. I remember they gave me this little slip to park in the parking lot, and it was supposed to say SpaceX visitor, but the X was kind of like washed out, so it looked like space visitor. I'm like, okay, and it was just like just janky little strip of paper that like you put on your
Yeah.
dashboard. I was like, what is this company? And I went inside, and it was like just like I was a kid in a candy shop. They were like literally building this giant facility, building rockets. I was like, okay, this is what I want to be part of, right? Even though I think like, they offered a pay that was like half of what Google offered me at the time, I was like, okay, I gotta have this experience. This is something I thought that wasn't even possible. You have to go for to work for NASA
Yeah,
if you want to work on these things. They're gonna be super slow. So ended up at SpaceX was the first time where I was able to combine this passion that I have for hardware and with computers, and for the first time saw people that wanted to do hardware development, the speed the software was being developed. And that was just super fascinating to me. And that kind of got started on my career in the overlap of space, aerospace and software. And since then, I have been in that space. So that kind of
awesome.
journey started like that. Yeah,
That's great. Yeah. I want to save personal stories maybe for offline, but yeah, it's reflective of part of my career as well. So maybe we'll talk about that outside of the show.
for sure.
So hear a lot about the SpaceXs and Teslas, obviously attracting amazing talent who go on to found great companies, obviously like yourself. Back in the day, it was what was the PayPal mafia, and then now it's all SpaceX, Tesla, etc. What was that aha moment that made you realize there was a better way to manufacture complex parts, and that you needed to go out and start doing that yourself?
Yeah, yeah. So when I was at SpaceX, I saw this like ambitious kind of vision, and raw talented people want to do this thing much faster than was ever done, with NASA and some of the government entities. Immediately, it was very clear that like the bottleneck is going to be making physical stuff, right? Every time we had to build any kind of a hardware, you have to pretty much build a factory around it. There's a lot of machinery, tooling, equipment that goes into it that is very specifically designed for the part that you're trying to make, for the material that you're trying to make. For example, at SpaceX, the diameter of the vehicle depends on the molds and dies that they have for the fairing, the diameter that the friction steel welder can support in terms of welding those sections together. And those are big investments, and they're pretty much locked into the geometry. So very easily I saw that, like, well, Peter Thiel used to say, okay, we were promised in the 50s and 60s flying cars, and now instead we got 144 characters, kind of we got Twitter or X. And kind of like people attributed that to, like, oh, it's just lack of gusto, right? Like we're just like,
Yeah,
we were focused on other things. But in reality, there are like technological challenges in terms of going fast in the hardware space. The reason we got Twitter instead of flying cars is that, anybody with crazy idea, like Jack Dorsey at the time probably, could put together a few lines of code. Yeah, I mean, not few hundreds of thousands lines of code, but then it's somebody that some small team can do, and put it on a server and serve it to anybody. The speed to get to the customer is significantly higher in the software world. And with the invention of like AWS and Azure's of the world, you don't even need to buy servers and data centers, right? You can just rent, and you have an idea, you put it, and now millions of people can access it immediately. That's not the case even today with hardware. You have to go build factories. It's a lot of physical capex investments before anybody can even get a part out. So I saw that very clearly at SpaceX, and then that's when it kind of started on this journey. I was like, okay, can we make factories that are kind of more like data centers, right? You can kind of like define a certain portion of this factory to manufacture a thing just through software. And immediately, once you're done with the design, that thing can start working and give you a part in a matter of hours and days, as opposed to months and years that you need to spend building the factory. So I saw that the first glimpse of it was at SpaceX. But then since then, I have tried different routes of it. I went to Relativity Space to see if we can put 3D printing, we can do that. And then we started Machina, which is a more holistic, more encompassing view of how automation for a factory that can build anything can look like.
awesome, awesome. I really want to jump into Machina and everything, but before our aspiring founders or first time founders out there, just like a slice of reality here, because founding a deep tech startup is never easy. What were some of those earliest challenges that you and co-founders faced in turning your vision into reality?
The biggest challenge, I think the biggest challenge is finding that core concept and idea that you're really, really, willing to bet your next few years of your life on, right? And I think so that requires a lot of conversations, a lot of kind of really deep, honest, technical, fundamental thinking to see, okay, what works in this space? Because once you set on your path, I think it's a very expensive both for you personally, but also like for your investors. But once we developed that conviction, which it took us like, maybe a year and a half to really develop conviction around how does the future of manufacturing can look like. I think we were lucky to have, a very good group of investors that supported us from previous companies that we knew. Always, I think in a company, the biggest challenge throughout the life of the company is people. I mean, at the end of the day,
Yeah.
company is the people, and you know this very well, right? Being the right people who are mission driven, aligned, and kind of stay aligned. I think it's probably the biggest challenge for a founder. I remember somebody famous, which I'm not going to name, so I don't want to drop names, but like when I was like starting at the company, I was like, hey, what advice do you have for me? And he was like, your job as a founder is to make believers, right? Now, that's making believers out of your employees and team that, this is worth them spending their energy versus going to work for Google or Boeing or Lockheed. Believers out of your investors, this is going to be worth, they're spending, their money on this and get a good return. And believer out of your customers. They're like, hey, like, I want to incorporate this crazy technology and it's going to be better for me in the long term, right? So I think the biggest challenge is like constantly making sure that you're honest and true and authentic about what that mission is and what we are doing and what is our approach, so that those believers feel like, okay, yeah, this is something I can believe in and I can put my life behind.
Yeah. Great advice. Great advice. Okay, so for listeners who might not be familiar, or maybe this is the first time they've heard of Machina Labs, what exactly do you guys do, and how is your approach to manufacturing fundamentally different from like traditional metal forming and tooling processes?
Yeah, traditional manufacturing, and we touched upon this a little bit. Traditional manufacturing is very locked into the design and the material you use, meaning that you want to build a specific hardware product, you build the factory around it. Elon Musk, famously used to say that factory is actually the product. You think about Tesla, the car is a product. It actually starts at the factory because factory is very custom built for that product. So
Yeah,
it's a factory that outputs the product, which is the actual product, right? And that's because, yeah, the factories are very much locked into the design and the material you're trying to use. And that has been a huge hindrance in how fast you can make physical product. So we started Machina to basically explore how can we build a factory that's not locked into the product. A factory that can easily manufacture car doors in the morning, in the afternoon maybe makes airplanes, aircraft parts, at night it can make UAVs or tractors. You just need to change software in this factory and it can do something else. So that's our mission at Machina Labs, building this next generation of factories. And the core thesis is we need to build a unit of manufacturing we call RoboCraftsman, that is a robotic system that can do different types of manufacturing operations autonomously. We call it RoboCraftsman because it's supposed to operate like a craftsman, right? It can pick up different tool, has the right creative almost mind to figure out how I'm going to apply this tool into the material and into the work in progress to get to the right parts. So it requires the robotic piece, it requires the intelligence. Those are the two core enablers, but it's a system that, it can do different types of manufacturing operations. Once you have that system, which we do, it's in our shop floor, then you can set up a factory, you put 50, 60 of these in there, and now this whole factory can program to be doing different types of operations. That's what we're building at Machina. We've deployed 2 facilities to the date. We're planning to deploy 2 more, but these are next generation agile factories that can build, different types of products that are not tied. Without easily you can change it from one product to another. They're not tied to each design or material.
love that. Love that. How do AI and machine learning factor into the process? And like, are the robots learning from each forming cycle or optimizing in real time?
Yeah. So in order to build the craftsman, right, you need two pieces. You need the dexterity of the craftsman. You need to be able to pick up different tools, apply differently to the material. Well, you also need the mind of the craftsman. So the craftsman mind figures out what set of operations do I need to do to get to accurate parts, and what process parameters. How much force do I need to apply? What set of process parameters do I need to come up? So there's 2 ways to come up with those with that with that mind, right? One is in a classical way. You program it. You figure it out as a human and then you program it. That has been the traditional way we get robots to do things for us. There's a static program that you load it and you can do that thing. The challenge with that is every time things change, you have to program it again, right? So what we wanted to do is that the robot to learn like a craftsman, learn from what it does, and then come up with these set of instructions and process parameters. So how do we learn that? Data, right? You need to get your robo craftsman to do things, right? Or at least in the virtual world or in the real world, right? So in the real world, you need to start making metal parts and then use the data from that making process to come up with mental models or AI models that can come up with the right process parameters. So we capture the data from the process and then use that to come up with the right set of process parameters to manufacture actual parts. We also then use virtual trials, right? Doing simulations in the virtual world to generate this data. And that allows us to generate significantly more amount of data than we could if we had been only doing it in the physical world. So the data is coming from the process, either in the virtual world or in the physical world. And then we use the data to train models to predict for the next part, what is the right set of operations and process parameters to use to get the right part.
Awesome. Okay. So you mentioned before car doors and then doing UAVs and etc. So a variety of things. So what industries are you actually focusing on today, and where do you see the biggest opportunities for your technology to make an impact next?
Our first, which is the case for most manufacturing technology, our first customer was aerospace and defense, right? Why is that? Because the main offering that we have, the main competitive advantage we provide is speed. How fast can we get to a part? If you don't have to go build a custom factory and a factory that's already built can get your parts, that's a significant advantage in terms of speed. And the industries that care about the speed come to us first. Defense cares about speed because it's a matter of national security, right? Our biggest customer ended up being actually depots in the Department of War, right? These are entities. These are giant actually factories that our military runs inside. Actually military themselves run these things, where a landing gear door of an aircraft gets damaged. How fast can we replace it? Right? Because if something on an aircraft that's need to be doing missions gets damaged, that means that aircraft stays down. So it's very important to bring that aircraft back up very fast. But the traditional way of going and building tools, some of these aircrafts are like 50, 60 years old. The tooling are gone, so they have to rebuild a lot of tools when it gets damaged. It takes years sometimes. For example, for a landing gear door of a C-130, which is a logistical aircraft for the military, if it gets damaged today, it's 4 years lead time before they can replace it, right?
4 years?
4 years. So that means that aircraft, it needs to stay grounded for 4 years before it can be repaired, right? Because
Why
they need to
so
go.
long?
Because they need to go. So I think this is, once you start looking into the underbelly of manufacturing, you will see it's actually pretty challenging to build things, right? So why is it so long? Because a landing gear door requires a mold and a die. This die is size of this, a big room, right? It's size of a car almost, right? So this die needs to first get manufactured. There's not a whole lot of people that have expertise in making this die. So if this aircraft is from 50 years ago and the dies don't exist anymore, you have to go and remanufacture this die. That means, there's 5 or 10 entities in the world that can actually make this. And then you limit that also within the US, that it becomes even smaller, right? Now, it takes few months, sometimes 3 months to 1 year to make a mold. Then you need to have a stamping press that can manufacture a landing gear door. These are like 4 or 5 presses in North America that big size. So we need to find those stamping presses, needs to make sure that there is enough kind of like time in their schedule to be able to use them for this. So it starts, and then there's also logistical issues and paperwork that, our military needs to go through validation and certification. So it takes a while. What we're getting rid of is we're completely getting rid of that die and getting rid of the need for that stamping press, right? You have robots that form that landing gear door like almost a potter forms a clay mold, right? They get to it and start deforming it in shape without needing any mold and die. So we can significantly cut that lead time into half, into sometimes half, into sometimes 50 times faster than was traditionally possible.
Wow.
So that was our first customer, Department of War, specifically for sustainment and mission readiness of these aircraft. Since then, we have made panels for C-130, F-15, KC-135, F-18, right? All these legacy platforms that when they get damaged, that have a very hard time finding spare parts. So that was our first customer. They cared about time and lead time, and that's where we provided them. But since then, We have also moved to the development side of the aerospace defense. We've worked with primes to, for example, manufacture UAVs 4 or 5 times faster than they traditionally could. So we are actually going to announce hopefully soon, but we are with one of our primes. We are entering into a production agreement soon next year to manufacture, airframes and metal structures for UAVs. Like I said, five times faster. And then more recently, this is the announcement we did couple months ago with Toyota, where for the first time they're using our technology to offer a new category in automotive that didn't exist before. Because factories are custom built, as we talked about, the way to make money in automotive business today is that you make the same car over and over again, and you better have a call following around that car, and everybody buys that same car before you can pay for the factory, right?
Yeah.
So that's the key to success. With us, for the first time, they can create serial number 101 for everybody, right? You can get a custom car. Greg can go on Toyota website and say, hey, I want my favorite sports team to be formed in the back of my Tacoma tailgate. And we can do that without having to spend, hundreds of thousands of dollars in dies and tooling. So we can start creating this mass customization in automotive. And it's something that's like everybody wanted it because cars are so personalized. We wear the clothes.
Yeah.
You and I have different clothes, but we're probably driving similar cars, right?
Right.
So we have this opportunity to express ourselves in clothes, but we don't have that opportunity in our cars. That's why, like they said, like somebody said, like 60% of the cars have stickers on them. So people are doing the customization in this janky, maybe not so aesthetically pleasing ways. So this, for the first time, we get the opportunity to actually design something that's uniquely yours. And I'm really excited about that application. So yeah, aerospace defense initially, now automotive. A lot of people care about lead time. Now we're enabling new business models that kind of create, uses this flexibility to provide something new for the customer as well, like the example in the automotive. But
Very
there's a
cool.
lot of other applications. We've been talking to, heavy industries, agricultural machinery, construction machinery. The world of metals is so big. It's like, $500 billion, $600 billion industry, right? So for metal structures. So there's a lot of opportunities. But we've been selective in those areas of military, aerospace, and automotive to enter the market and then expand from there.
Yeah. Love that. Yeah, I didn't even realize the B2C element there with the automotive side. That's really cool because people who, if you are a car enthusiast and you want to put all your money in there to wrap your car or do custom wheels or whatever, it's so expensive, right? But if you can do something straight from the OEM when you order it, and yeah, that's really cool. I didn't even think about something like that. Awesome, awesome. And we spoke offline briefly just about the new announcement that you guys had recently over in the UAE. So I'd love to hear a bit more about that and for you to share with the listeners as well.
Yeah, absolutely. I think we're kind of in an interesting time. So I'll talk a little bit about the UAE. It's an announcement I think is very unique. It's a partnership that we're going to do within the UAE, and they're also investing in us up to $35 million over the next year. They already started making that investment, and there's a few milestones collaborative we're going to achieve. But the goal is to enable our allies to also do local manufacturing to support either defense products, but also commercial products. I'm excited about this because I think, in the defense world, people don't think of factories as, as a defense system, right? They think of, oh yeah, the factories make the defense system. But the reality is like, the same kind of concept, like we said, Elon said, like factory is the product. In the defense world, also the real conflict happens, the real competition and conflict happens in the factories. If you can outproduce, if you think out World War II, if you can outproduce your enemies, you're in a much better position to win a conflict. Unfortunately, since 60s and 50s, we have slowly kind of outsourced our manufacturing capabilities to other countries. So we have lost our ability to manufacture ourselves, which has become a huge national security threat, right? We build a service economy on top of manufacturing in other places, but it's a pyramid. They can pull the rug from underneath us, this whole pyramid collapses. And we are seeing some of those nations that we know that we built this pyramid on top of starting to act a little bit hostile, right? So we're thinking about bringing this capability back. A lot of people thinking, oh, we need to go back to the 50s and 60s paradigm. Centralized manufacturing plants in the United States that can make a lot of defense systems. we think that we can actually go forward and build the next generation. And that's where we come in. So the partnership is we're planning to set up a facility in UAE that can manufacture components for our allies and friendly countries in the region that has a lot of turbulence, right? In the Middle East region, to create more stability. But this is only possible to do because of our technologies, because now the factory doesn't take 3-4 years to set up. We have these portable robo craftsmen that can, they turn into containers. They can be shipped anywhere. They can open up on any warehouse floor. They can self-calibrate, and the same day you start manufacturing parts. So you can not only manufacture parts fast, you can set up facilities fast. And this gives a huge advantage from the military perspective. You can set up a facility
Yeah.
in a friendly country much faster than you traditionally could. If you have a conflict in the Middle East region, we can set up a facility in a friendly country in that facility and start manufacturing components for defense products in a matter of months, not years, right? So that's, I think, the next exciting paradigm that we're exploring with partners in UAE to make metal structures for defense and commercial products significantly faster than was traditionally possible, and give this like kind of advantage back to the military, which is a new advantage that didn't exist before. Going from that central
Yeah.
paradigm to this distributed model.
It's this world of, struggling with supply chain fragility, and then also like these long lead times and everything like that you guys are trying to mitigate, right? And helping companies produce parts faster and locally and at the drop of a hat, really. I'm not something I was planning to ask, but just knowing your background and then what you're saying, basically this manufacturing in a box, you can just ship it and set up. Down the line is like off-world manufacturing on the horizon. Is that something you guys are doing already or thinking about?
Yeah, I think, it's kind of funny. I think, you know, any technology that I think we are nomad species, right? Like if you look at our history, we constantly moved around, right?
Yeah.
So any technology that kind of stayed with us needs to be portable at some point. So we did have that in mind. I think actually my initial interest in this space was not necessarily defense world and all this stuff, was excitement about, tomorrow we go to Mars, we go to Moon. We cannot take a 4-story, stamping press that can barely move within the country, well, even on the surface of the Earth, with us
Yeah.
to Moon. There's a story about, when Elon set up the first facility for Tesla, um, the cost of moving the first stamping press was higher than the price they bought it, right, across the country, right? So because these are giant equipments, right?
Yeah.
It's moving them is not easy, and our biggest challenge in kind of going to space is we cannot move a lot of heavy things with us, right? So having a robotic system that can do many different types of operation is a key enabler for us to manufacture off-world, right? On the
Yeah.
surface of Mars, on Moon, taking advantage of the alloys that exist in the asteroid belt and making things. So yeah, that's our long-term view. We are proving it on Earth, and then we're going to send it out. We actually already have some contracts with NASA around, kind of evaluating this option as a kind of manufacturing the box that can go to space. And it's pretty promising. But that's definitely the view in the next 5 to 10 years, probably.
Amazing. Glad to hear it. I want to talk a bit about innovation and the future of manufacturing in general, because you're combining three cutting edge fields, right? Robotics, AI, material science, all for this new way of manufacturing. How do you balance the pace of innovation across these domains?
Yeah, no, it's like a new breed of company, right? Like,
Yeah.
back when I was in college, every company was doing mostly like all these venture funded companies were software companies. So like
Yeah.
basically it was a group of software engineers. Everybody kind of spoke the same language. Now we have this like new breed of companies where like very multidisciplinary. First, I think you'll need new type of talent, right? And I think that is understated, but it's actually the new type of talent that's not scared of learning new things. This had to break for me when I was at SpaceX. For example, I came in as a software engineer, and I had to learn all these other things. And initially, it was pretty daunting, right? It was like, oh, like, am I supposed to learn like FEA simulations and, and CAD design. Like, seems like that's not something that people go to school for. And they're like, well, we need to do this and there's not enough people. So do you want to learn it? Right. And that broke for me. I was like, okay, maybe I can go learn these things. So first biggest thing is like you need this multidisciplinary talent. And I think it's pretty rare. So we need to make a lot of changes in the our education process to kind of generate these type of multidisciplinary talent. Um, but then, to your actual question, within the company, once you have the talent, it's a little bit tough because like, traditional view with these complex systems was like, lock yourself in a room, design something that works in the lab and then come out and commercialize it. It's just not how a startup works. A startup works within, 2-year life cycle, 18 months of kind of runway before they hit a milestone. So we had to become very practical. We had to be like, okay, what can deliver value to the customer, or what is the biggest risk? And let's just almost, do the minimal amount of things we can do to de-risk that and then move on to the next thing. That means sometimes we're redoing a lot of stuff, but then we show incremental progress and we're not locking ourselves in the room to build something that by the time we come out, maybe it's just not even needed anymore, because
Right.
it's really tough with this multidisciplinary kind of products to really get into that mindset. Oh, I'm just going to go build it and I need to have a group of experts sit down together and figure this thing out. It's going to take forever. We need to almost figure out, okay, what is the biggest risk? And sometimes it's a hacky way of doing things, right? But then over time, the system, over iterations, it becomes better and better. Versus, it's a one fully well thought out thing right off the bat that takes forever. Um, so I don't know. Does that answer your question? It really comes down to
Yeah.
practical outcomes. Can this system build stuff for customer? I mean, this is day one for us. I mean, even when we started the company, few months in, we set up this first hardware system, and the goal was to make parts for NASA and Air Force, which were our early customers at the time, and do it however we have to do it. Right? Doesn't need to be the right way. We need to just de-risk and make sure the system can build parts, and then after that, we iterate and improve it, which is not an intuitive way to do these things, and it's definitely engineers, get a little bit
Yeah.
uncomfortable about it. It's like, oh, I'm kind of putting things out that are not fully figured out and fully well thought out, right?
I think what you're saying really is that clear balance between commercial use case and viability, right? And then perfectionism, because that you can get caught in like building in a vacuum or complicating, over analyzing, over perfecting something that you'd like just get it to market. Early customers get the feedback, refine it over time, get that adoption, and then you can make it better. You can't just build it in your garage and hope that it's going to work commercially.
Yeah, exactly. And that is much tougher in these multidisciplinary systems because people feel more fear. They're like, okay, I can do the software piece in a hacky way, but is the material science piece going to come along? Is the mechanical piece
Yeah.
comes along? And that's why you require talent that can bridge these disciplines and kind of see a little bit of a more, holistic picture. And that's the toughest thing. It was much easier to do what you just say in a purely software company because everybody speaks the same language. Much
Yeah.
harder when you have all these disciplines that people are not aware because they're going to be fearful. They're like, okay, yeah, I can do my software piece, but like, does the hardware can catch up with that? Or how does this mesh and interface together? How do we going to create a, you know, milestones that are de-risking company and it includes parts that I don't fully even understand, right?
Oh, the risk is also so much less if you're just building like an app or a SaaS product or something like that to get it out and be like, okay, we can fix those bugs as we go. But if you're building hardware, you're working with aerospace and defense, it's like, can we or should we, trying to talk people down from over analyzing that. Let's talk more about talent in general, because obviously that's where I focus. And also, I'm curious about how you guys have built your team, because anyone not familiar with LA, you guys aren't like right slap in the middle. You're in your own area, obviously for space and all of that stuff. LA has a huge amount of talent for aerospace, defense, manufacturing, and a great place to live in general, depending on your stage of life. You can get whatever you want. How have you guys gone around piecing together your team, your initial core team, and then scaling once you've kind of hit this velocity and, you know, more interest commercially?
Yeah, I think, that's an active problem we're trying to solve, right? I think this is an area because of the reasons we just talked about is that talent's actually pretty tough to find. Multidisciplinary talent. I think early days, was all about people we knew, right? Who did I know from SpaceX? Who were my interns at Relativity Space? All the pieces that, or other team members knew, right? And I think that creates a very initial team that actually, has good experience and have some background together. But the moment you start going above 40, 50 people, that just doesn't work anymore, right? And now
Yeah,
we're like, at 70 people, we're planning to become 250 people in the next 2 years. So we have to think outside of that. I think one real easy choice is like, we need to also just think about other geographics, right? We need to break down now, it's more and more so break down into expertise that we need. We still need a lot of multidisciplinary people, but break it down to core expertise. So the leadership needs to start thinking about how it can divide up into core disciplines and then get closer to those talents. We haven't, ruled out having an office in the Bay Area. We are opening up our next facility in another state, getting closer to talents, maybe in Texas and other places. I mean, that's a problem to solve.
yeah,
I think, the main answer is like, we need to get closer to the talent. We are fortunate in LA. We're in an area where, slightly further away from the core excitement, Segundo, El Segundo, we're slightly away, which has one benefit, which is like, once the talent comes here, they're really passionate and excited to work with us. But also we don't take advantage of the, kind of maybe a talent arbitrage that constantly happens in the area of, a lot of excitement. Um, but it's an active problem we're trying to solve. I don't know. Do you have
yeah.
any thoughts?
Lots of thoughts. Um, we work across the whole of the US, and I speak to clients in a similar situation, right? They might be in the Bay and they've got space and cash constraint because building stuff like you guys, you need the space, you need the talent, and that just like eats away at capital because cash is king at the end of the day in hardware, right? Then you've got like the emerging or like resurgence in the Detroit area, or like you mentioned Texas, that a lot of cool stuff's happening there and your dollars go a lot further, but it's attracting the talent to go there. I mean, robotics has its hubs, right? Bay Area, Boston, Pittsburgh, and then LA's got a lot going on. But what you said about hiring the core team from your own network and your referrals works great until you exhaust it, and then it's trying to go outside, and a lot of it is doing a lot of marketing around for talent, deciding where your hubs are going to be, and then, as you mentioned, what core expertise or specialized expertise can we have satellite divisions. You could even end up with like, we're going to have a small office in El Segundo to do certain stuff and have an expectation that some of the team are coming up to HQ once a week to implement, test, etc. Or Bay Area, we're going to do a lot about ML, AI. I don't know if you guys are doing any reinforcement learning or anything like that, but there's obviously a centralization of people up there, Seattle, Boston, that you could take advantage of with an expectation of coming to HQ somewhat frequently. But you need
Yeah.
someone capable in those locations to lead the team and embed the culture. It's hard, it's one of like the main problems for hard tech robotics companies because there's the physical element, but the talent is distributed. Yeah,
Yes.
we can talk more about it offline. There's things I'm implementing with other clients right now, but yeah, it's not an easy problem, and it's not unique to just you guys. So I've I've been helping some with figuring out locations as well. How can you be central enough to take advantage of the Orange County, El Segundo, Long Beach, and LA talent, right? But you just got to put a stake in the ground at some point, which you guys have done. So kudos. Why did you pick that location? I'm curious.
I think, I wanted to stay in LA because, the initial network was in LA, coming from Relativity and SpaceX. But the location was actually it was, maybe this is a good also founding early founder stories. I think we actually rented a warehouse of space from an already existing large, aerospace company. The founder of that company was really excited about us. And they were in LA region, so we wanted to be LA region, but we didn't go to the hype region of like, El Segundo because this founder of this other company told us, hey, like, you can use the back of my warehouse and you can just pay in shares for now. I don't need cash from you. And it was a very good offer too good of an offer to refuse. So we started that way, but then we opened up another facility next to it, very close to it, because as you can imagine, also like the big challenge of having multiple satellite offices is, we have two locations now, but the cultures start becoming different, right?
Yeah.
Even like we are like literally like 10 minutes apart, 5 minutes apart,
Hmm.
but the two buildings have different cultures. Depending what teams are operating in there, what cadence of kind of delivery they have. And so we have two facilities here, but the initial stake on the ground was because we have this supportive landlord in the region, and it was in LA area, so I think it was not too far from where I wanted to be. But
Good.
it was a good deal.
Yeah, yeah. The culture thing's interesting because as the company grows, you get past that initial network, as you mentioned, your network and your referral network and stuff like that. And I've seen it even in companies. And I actually like advise clients to not get so bogged down with it between teams because when we hire, we're like, okay, what's your company culture? We need to be clear on that. Like, what are the core principles and candidate profiles you look for across the board? But every team's different, right? Your sales org is going to be very different to like if you have a research team, for example. I mean, those are two different extremes, but I think, and they can be in the same office on other sides or on different floors, but they're going to be drastically different, but part of the same core mission, same core culture, and visions. It happens as you scale and grow, but different locations definitely throw a spanner in those works.
Yeah.
Um, I'm conscious on time, and I respect time. There's a few key questions I want to ask, some advice for people as well, and just like realizations. How has your leadership style evolved from being an engineer, working at some of these other very innovative companies, and then now being founder CEO?
Yeah, I think, it's, yeah, I think, I remember we did this like a leadership style kind of like workshop when I was at Relativity Space as part of the early team there too. And, at the time I was, my style ended up being somebody who runs ahead and then, kind of sets an example that people follow. Like, try to work hard. I try to be in the office as much as I can, work on problems, be hands on as much as I can be,
Mm-hmm.
to set the pace. But I think as the team grew, especially in our company, I think that type of a communication, because everything is a communication, right? You come in and you set the work pace. The way you work is a communication. But if the team is big, you know, then that communication of in person and physical gets much harder. Not everybody sees that. Your immediate team sees that, but the rest of the company doesn't see that. So I think one of the changes I have noticed in the past year or two that we had to implement is that my style need to change from being a body language, physical style of like, let's go do work together. I still do that, but it start really be able to break down, break down what we are after, what are we trying to build, and communicate that to the team. Right now, for example, I actually write a weekly, I call it a yap log, but I write a weekly kind of like, few paragraphs of like, what are we doing right now and why? And the answer questions in the company, because now we're getting to the scale where I cannot have conversations with everybody, right? So
Yeah,
I had to start developing these new tools to get the team aligned. And I think, yeah, communication of how do you communicate with a larger team, I think it's a skill you need to develop. If you're a doer leader, I think that's a skill that you might not have as much. And over time, you start need to figure out, okay, how can I verbalize these things? How can I write essays and communications and things that the team can and can read and then get aligned and or ask questions.
yeah.
So that has been a little bit of a change in the past 2 years. I'm developing that skill more and more.
I like that. I like that. All right, before we go, one last question that I think everyone will want to hear, but also probably for you to just get it out there. If Machina Labs achieves everything that you guys envision, everything that you set out to do, how will the world of manufacturing look different by 2035?
Yeah, I think you know freedom of expression. I think really it's a core value for us, right? Like, and then physical expression, like actually building things. You look at the world today, it's pretty, I mean, people don't realize it because they don't, but the world is actually, from design standpoint, is pretty boring. If you go to major cities, most buildings look like each other. Most cars look like each other. planes look like each other because we cannot be expressive. So I think if you are very successful, with the most version of successful the Machina can be, where anybody can get to any portal. You have an idea about a physical product. You can go to this Machina portal. It helps you with AI to design something that's really coming out of your brain and turn it into a very accurate design of what you had in mind. And then matter of days manufacture it and send it to you, right? In whatever volume that makes sense. Program the right facility in the right location to build it, program the right robo craftsman to do the right operations and get it. And I think the outcome representation of that would be that the hardware world will start looking like software world, where the speed of iteration significantly increases. And what does that mean is that obviously, yeah, reliability, all those things improves because now we can iterate faster and figure things out. But the outward presentation, the world will look very different. We're going to see whole variety of new designs available. Like cars, they're going to be like everybody will driving a different car. Everybody will be living in different types of a building. The expression, the physical expression, will become like what you see in sci-fi worlds, where there's this like variety and complexity of design that exists in on Earth and outside of the Earth. That's inspiring. You'll be like, oh wow, like like everybody's fulfilling the way they want to express themselves in this world, and that's a possibility for everybody. So that's I think what I'm excited about. Hopefully by in the next 10-20 years.
Awesome. Great point to leave the show on. I think. I mean, we could have carried on talking for another hour at least, but like I said, conscious of time. Thank you so much for being on the show today, Ed. Really appreciate it, hearing everything about what you guys are doing and your journey. And it's a pleasure to have a local SoCal success story on the show. So thank you. Um, where can our listeners learn more about you guys, follow along, and maybe get in touch if they're interested in getting involved?
Absolutely. Yeah, no, thanks, Greg. Yeah, we're on major, social media platforms. You can find me on X, the company on X. We're also on LinkedIn. We're on Instagram. And if anybody's interested to kind of start, we are always hiring. So if you're interested, check out our career page on machinalabs.ai. And then if you have any questions, send to info@machinalabs.ai. Yeah, we are always looking for ambitious, mission-aligned folks that are trying to build the expressive future we talked about.
Amazing. Yeah, thank you again. And I look forward to keeping in touch.
Same, Greg. Thank you. It was great talking to you.